Alright, if you don't have any questions, we will proceed with the next transformation. So in the last class, what we were looking at is the validation transformation, and after that, we will look at the map operation and then proceed to XML map, query transformation one more time, how to handle the nested structure, and then we have one more transformation called as XML pipeline in the integrator. So these three deal with the XML structures. So I look into these three together to understand how these three work, so that when you get into XML structures or NRTM structures or nested structures, you can better judge like which transformation will fit when exactly. Alright, so the next one out of the platform that we'll be looking at is a map operation. So what is a map operation? So if you look at this, it says modifies data based on the current mapping expression and the operation codes. So what is an operation code? Right, so if you are a bit familiar with the database, we have something called as opcodes or operation codes, which will tag along with the data. So the different set of opcodes that we have are inserts, updates, and deletes. And we also have before inserts, before updates, and after inserts and after updates, but generally we will not be working along with them. We will be looking at inserts, updates, and deletes. So this is one of the topic that we will cover along with the change data captures, the CDCs, where there is a change in your source data that will get you only end up reading only the delta records and you update that, and right. So these kind of insert, updates, and deletes are called as the opcodes. So let us go back to the map operation definition. It also says that it allows a conversion between the operation codes, right? So first thing is, map operation is a transformation that understands the input data which has opcodes on it, and the second thing is, it not only understands the opcodes, but it also allows you to do a conversion between the opcodes, wherein you can convert an update to insert, insert to delete, delete to update, update to insert, however you want. Because let us say we will have a question now that why I want to convert a delete to insert or a delete to an update, right? So there will be some business cases that if the record is already present, or if it is coming with an opcode D, you rather don't want to delete that but want to keep it in a separate table as a new inserted record, right? So in those cases, definitely we will want to capture those records and keep them in a separate table. And when you say keep them in a separate table, it is an insert. So there will be business scenarios where you want to convert the operation codes, and this is the best transformation that we'll use. So along with the map operation, we'll look into two different scenarios now. One is, how does this map operation work? And the second one is, how can we debug the code? So this is one of the most important thing when you especially are working with, because map operation, it kind of shows you, when you run it in a debug mode, it will kind of show you the outputs or what exactly is happening between the table and the transformation and after the transformation. So to capture these things, we are trying to run this map operation in a debug mode, and along with that, we will try to learn how does this debug mode work. Alright, so let us start building a job for map operation. Alright, so let's create a data flow. Now open the data flow, pull any table, and let me take orders and make it as a source. So one more thing that it is not mentioned in the definition of the map operation, but if you are using a map operation within your job, the next transformation should be something that understands the opcodes, or it should be your permanent table. Remember this, whenever you are using a map operation in a job, the next transformation, or let me put it this way. Okay, so when you are using a map operation, let us say this is in my data flow, this is my source table, and after that I have my query transformation, and after that uh, another transformation, and let us say this is my map operation. Right, the transformation that you use, if you are planning to use any transformation next to a map operation, so this should be in a position to understand the opcodes, right? Or if it is a table, if it is a transformation, it should understand the opcodes, and if it is a table, it should be a permanent table. It should not be a temporary table, because these data that flows from your source table, it is tagged with opcodes, insert or update or delete. So these flows through the transformations, and then once it reaches the map operation, or to be more precise, you should not have any transformation here. Once again. Alright, so your source table, which feeds the data into the map operation, which has the opcodes. Alright, and now this map operation understands these opcodes like insert, update, and delete, and they will try to, if you want to do a conversion, then it will do a conversion from insert to update, update to delete, and delete to discard, or discard to update, or whatever it is. And then finally it will push into the subsequent transformation. If the subsequent is a transformation, that should understand the opcodes, or if the subsequent object is a table, it should be a permanent table, because this data is getting pushed. It is a DML statement. It gets pushed onto the target table with these opcodes, like these set do an insert, these set do an update, and these set do a delete. Just make sure that you can this can be an interview question, that can I have a template table next to a map operation, or what kind of transformations can I use right next to a map operation, or what transformations can I use before the map operations. So any transformation that can push the opcodes can be used in front of map operation, which means you can use one map operation followed by another map operation transformation. So let us build a scenario here. Okay, now let us build a scenario using the map operation transformation. Chandra, you have any problem here?
Yeah, Rakesh, I lost my connection just now. I connected. If you don't mind, please explain just briefly once again.
No, this is a transformation which use the map opcodes to capture the data changes. Right, so that's what I'm saying, like when you are using a map operation, right, the preceding transformation, if you are trying to use a preceding transformation, this should be in a position to understand the opcodes, or if you are trying to use a transformation after your map operation, that should be in a position to understand the opcodes, or it should be a permanent table. So we are trying to build a scenario against it. You can see that, and probably you'll understand. You did not lose much, Chandra.
Okay.
Okay, yeah, can you be on mute? Thank you. So now if you look at the map operation, I'm just selecting and dragging it into this one, the data flow. We'll try to build multiple scenarios here and see how this map operation works. So first let us understand what is this map operation. So if you look at the graphical representation, greens are converted to oranges, which means the opcodes, right? You cannot have an exact depiction here, but you can easily remember these transformations this way, that you don't get confused when you start working on this in the initial days, right? The data is getting converted, right, from insert to update, delete to insert or something. Now if you open the map operation, right, it is divided into three regions. So which says that this is my schema in, this is my schema out, and the relationship between the schema in and schema out. So let us say if a flat file is sending a table or a data, or a table is sending a data, then sorry, there will be no opcode on that data, right? So it is a very normal data. So you keep normal to normal. If it is like a flat file or a source table, then you don't need to keep this map transformation as well. But let us say you wrote an update statement and your data is sending as or coming in as an update. Right, you need to capture that, and we want to convert that on the right hand side output row type. You can switch between the opcodes, right? Right, so you can do a normal to normal, and you can convert update to insert or update to delete, or you can just discard that kind of operation. So let us say when I'm trying to do a comparison between my source table and target table to identify the records. So a very good example that we can talk about is like an organization data. So let us say I have an organization data with employees, and this has to be updated on a monthly basis, but for some reason that HR has forgot or something has happened, and this data was not updated over like last 6 months. Now you go into the system, and in these 6 months, right, there might be so many changes in the organization, right? So many people must have got promoted, or so many people have left the organization, or new joinees must be present in the company. So if you look at this data, the new joinees are inserts, right? People who got promoted are updates, and people who left the organizations are deletes, right? So these kind of changes will be there on the data which you need to capture, right? You cannot just go ahead and overwrite the data or delete the data, or you just cannot keep whatever is current on your system and start working on it, right? So you have to carefully compare your source data to target, and then you try to understand which is the current record, which is the updated record, which is the inserted record, and so on. All right, so I'll just do some scenario here. I'll just call this as map operation normal. Then the second one is map operation normal to insert. I have to do the changes in the transformation. I'm not doing any. I'm just creating a flow here. Then this will be insert to update. Randomly just showing you what are the possible things. Normal to update. Update to delete. Delete to insert. Right, just building a flow. Insert, and then so here, just for the demonstration, I'm using the template tables, but make sure if you are using any template table, uh, it will not show you the proper result. You should keep a permanent table as a target so that your opcodes get pushed out to the target table. So this is update. This is this is
Rakesh?
Guys, sorry, lost my connection. Sorry, I lost my internet connections. Guys, request you to be on mute. Okay, everyone, please get back to mute. Chandra's, yes. Alright, so here I'm keeping this insert to insert, and then right, I keep this normal to normal. I keep this delete to delete. Alright, so I'm trying to capture the different sets here, but make sure this transformation, if you are using, and if you are using a table as a next object, the table should be a permanent table, but just for the demonstration I'm using this as a template. When you are working on a project, just make sure that you are using it as a permanent. Now let me run the job, or let me run the job in a debug mode. Right, so we will see how to run the job in a debug mode along with the map operation transformation. Now to run the job in a debug mode, you select the job, right click, and go for start debug. So this is one way in which we can run this job in a debug mode. Or you select the job and go and click on the start debug mode in the menu bar, or press Ctrl F8 on your keyboard. So these are the three different ways in which you can go ahead run your job. So I'm just running it in a debug mode. So when you debug your job, so in SAP ABAP we use F6, and then in Oracle use the page breaks, and or any coding language use the page breaks, and you start working on the code. So which means within that block of code you want to see the output, what exactly happens. The same way we will be doing this activity here. So once the job is successfully completed, it will ask you, do you want to exit the debug mode? Just click on no. You can just minimize or close this additional windows. And when you are running a job in a debug mode, you will see this red color bug on the screen which says that you are still in a debug mode, and if you want to exit a debug mode, you can stop debug, or you can click on this button to exit the debug mode. So how is that different from a normal execution? Now if you go to the data flow and see, you will see the intermediate magnifying glasses. So previously we never had them. We had only the source table magnifying glass and the target table magnifying glass, but now we'll have the intermediate, like what happens between your source transformation and what exactly happens after your transformation. So if you are using a table, then you can go and look it in the table itself, but you are using multiple transformations in a row, then you want to see what exactly happens between the transformations, then you can run the job in a debug mode. Right here, the data flows out of a table as a normal, and since this transformation is normal to normal, right, sorry, I haven't done any changes on the job. So let me close this. I think I lost the connection and I thought, right. So to do the changes, right, so we are keeping the first one as normal to normal, and inserts, updates, and deletes, we will discard them, right. Just showing you the scenario, guys, how to work with the transformation. The second one is normal to insert. So this is where I'm converting a normal to an insert opcode, which is I'm tagging an opcode with the data, and all the remaining things I'm discarding. You can do all the inserts, updates, or conversions in one single transformation, but I'm just doing it in a separate transformations to let you understand it properly. Then here, my assumption is now the normal data set is converted to an insert with this transformation, and after this transformation it will have a tag of insert on that one. Now I'll go and convert this insert to update, and I'm discarding all the remaining opcodes. Now this one is normal to update. So I'm doing all these conversions from normal because the source data set that you get from a table is obviously a normal set. So there will be some tables in Oracle called as CDC tables or change data capture tables, which will have an additional column called as an opcode column. So there is a separate transformation to handle this. Now this is normal to update, and this is update to delete. You convert update to delete. Now you convert delete to insert. Oops, sorry, I had to keep discard here. And this is delete to insert. Right. So I'm done with the transformations. Now let me validate the code to see if there are any errors. No errors found. And let me run the job in a debug mode. So once your job is successfully done in the debug mode, so debug mode, remember, it will not take all the records, it will take the first 500 records because you're not doing a testing on the entire dataset, but you're trying to debug your functionality, whatever you have written. Now this is a normal set which flows out of the table. And since this transformation is normal to normal, right, I discarded all those things, the data set is still normal. Right, you are not doing anything. And one thing you need to remember is when you are in a debug mode, you cannot do any changes here. Right, everything is locked. You cannot do any changes. You can just go forward or come backwards on the screen, but you cannot do any changes on the transformation. Now for this is obviously a normal set, the one in the magnifying glass, but here we are trying to convert normal to insert. Now you click on this magnifying glass, you see an I opcode on the data set which says that this is tagged with an insert opcode, right? And after this one, it is inserted, and now we are converting insert to update. Now if you click on this one, this is converted to an update opcode, and it gets pushed onto the target table with those records to be updated. Now this is normal, and this is normal to update. You click on this, it has an opcode of U on the data. The next one, this is update as well, but here after update I'm trying to convert that to a delete. Now this has a D opcode on that one, and here after delete I'm trying to convert that into an insert. So that is the reason why it has an I opcode on that one. So this is how this transformation works. But when you work on a project, just make sure that you need to capture some updates, some inserts, and some deletes from a single table. And you'll not be using these many transformations, but you'll be capturing all those things in one single transformation map operation. And if you want to convert those opcodes from normal insert to update or delete to insert, you can do those changes in this map operation. Now you want to get out of this debug mode, you can click on stop debug, which will remove these magnifying glasses, and now you can go and do the changes on the code if you want. But when it is in a debug mode, you cannot change that one. And that can be an interview question as well, because you know, theoretically, if you read about the debug mode, it will never tell you like once you are in a debug mode, it will not allow you to do the changes, right? So that is something that you will learn when you have a hands-on on this one, right? So this is how the map operation work. Any questions on the map operation?
Generally, it will use for to like a construct data warehouse, like data warehouse tables, like right,
Yeah.
more data, load
So
data
you
in
will
fact.
have a table, which is like historical table, and on those table, if you want to capture those newly inserted records or updated records or changed records, yeah,
Like
CDS, change data captures.
yeah, data loading into fact tables.
Yes.
Okay.
Yes, Adil, you have a question? Sorry, I'm not able to hear you, Adil. Or you can ping me if you have any question, Adil, not a problem. Yeah. So this is the map operation transformation, and remember, the next transformation to your map should be a transformation which understands the opcodes. If you use a query transformation and try to push it into the target table, the query transformation will nullify all the opcodes. So only a permanent table or another map operation transformation, or there are a couple of transformations which understand these opcodes, will support these map operation. Right, and the last but not the least transformation is XML Map. So we will see XML Map with three different transformations. Right, so we were talking about the XML. So what is an XML structure? So XML is nothing but extended markup language, and it is nothing but the code in which your web pages are written. And if it is an Explorer, I think you get an option to go and see the view source code of any page that will give you the XML code, right? So what is an XML data? The data that is present in a nested structure. So what is a nested structure? What is a plain structure? So if you have a table like this, which has columns and rows, then you call this as a plain structure. Data flowing in from the flat files, flowing in from your tables, database tables, SAP tables are all of a plain structure. But what is a nested structure? So nested structure is you will have a region code. Under that you will have a area code, and under this one you will have and under this one you'll have the postal codes. Right, Adil gave a close business real example. So product tables with promotions, specials, discounts over a period of time. So you're trying to say with this transformation we can see the changes over the time. So sorry, Adil, you are asking about the map operation, is it? Yeah. So map operation, you can handle all these kind of things that you ask, right? So using map operation, you can capture the changes, or like let us say there is a stock price that is changing quite often, and it keeps fluctuating, but you still want to hold in one table the entire history of it. So what you do every time you update it, you rather than updating the existing record, you want to save that, which means you are trying to preserve the history of the data. So in those cases, you can use a map operation and convert it from insert to or update to insert. Right? There will be some situations where your you your client is hiring some contractors for project A, and once the project is done, they will rehire or reprocess the same contractors for project B. So which means if project A is done, contractors will have start period and end period, right? So once this end period is reached, which means their IDs are deleted in the system. but they don't want it to be deleted because they don't want to restart it from the background checks and all these things. So what they do, they instead of deleting those records, they keep them in another table as a flagged deleted records, but the records will still remain in the table. So in those cases, what you do is you do a conversion between delete to insert. Is it clear, Adil? So this map operation allows you to do a conversion on the opcodes. Okay, perfect. Thank you.
Can we retrieve the deleted records?
Sorry?
Can we retrieve the deleted records?
See, let us say if the record is not present in source and not present in target, then there is no way we can get it. But the system is marking those records as deleted. Let us say in your employee table, right, the transaction employee table, Chandra, Adil and Rakesh, these three people resigned the organization. So what the transaction table will hold, it will hold them as, mark them as delete, and it will remove those records. But you know, this Chandra, Rakesh and Adil, they have to go back to the organization and claim for their employee bonuses or, you know, tags or PAN or whatever it is. So it should be present in some historical table. So in the historical table, they cannot go and delete that record, but they do a conversion from delete to insert.
Okay, thank you.
Yeah. Alright, so nested data is something like you have a nested structure, which means you have a higher level of data, then under that you have, you know, next code, and under that you have a level, and under that you have a level. So for each and every record, which means like for country, USA, I have multiple regions like North Carolina, South Carolina, then I have Chicago, right, New Jersey, and under this I'll have different area codes like Hickory and XYZ and XYZ and so on, Greensville, right, Chicago, it's Lake Forest and some XYZ place, right. Again, you will get the postal codes, right. Hickory has multiple postal codes like 28601, then it has 28602 and so on, right. So for this is a hierarchical data, right. So this is nothing but your nested structures or XML data. So when you want to handle this kind of data, yeah, so if you want to handle this kind of data, you can use this XML structures as your sources, and when you have an XML structure as your source, then you can use either query transformation or XML map or XML pipeline transformation. These three transformations will allow you to handle the XML structures, right? So I have few XML sample files which I'll be sharing with you or with the training coordinators once the class is done. So they will be sending out these things to you. Right, so these are some sample XML structures that are given along with two documents. One is manipulating the XML data and the second one is real-time jobs, which we will be looking as a part of our training a little later, but now we are talking about the transformation. So these two we'll talk about them a little later, those PDFs that are present in the document, but as of now, to understand how this XML structure looks and how data services works with that, we will see three scenarios. It's like job underscore this is df underscore read XML, and what are the three transformations that can understand this XML data. One second, guys. Right, so first we need an XML data, right? So How do we tag the XML data into the system? Right, it is added just as a flat file to your system. Just give me a second, guys. Alright, so first thing is you need to add XML files to your data services system just as you add a flat file. So XML files will be of three different types. One is your three different extensions, I can say. One is XSD, which is XML schema definition, then .dtd, which is data type definition. This is again an XML structure, and the next one is .xml. This is the data file. So if somebody says that I have a data file which is .xml with an XML extension, can you read that using data services? The answer is absolutely no. We cannot read the XML data directly into data services because we need the structure files. So these two are the structure files. Either you need an XSD or a DTD for you to read the .xml data. So when you go to the formats tab, right, in the previous version you had like something like XSD, DTD schemas and all these things, but now in data services, now in the current version it is clubbed into a single thing. But if you want to cross check this, you can go to new, and you can see the DTD schemas, XML schemas, JSON and all these things. One second, guys. So these are the different types of structures that you can add. JSON stands for JavaScript Object Notation, and this is one of the recent coding language which is again holding the nested structures, right? But this is clubbed into a single thing. So you select the nested schema in your local object library formats tab, right click and go for new, and then you can go and choose whatever you want. You want a JSON, you want a DTD, or you can go and select an XML schema. So let's go for data type definition DTD. It takes you to this window. Now you click on browse, and there is a folder that I placed on the desktop which has these structures, right? And it shows me one XML document type definition. Just look at the description here. Once again. Okay, you can go and look at the descriptions a little later once I share these files. This talks about the data type definition of this, because I guess there's some lag in the internet or some. Okay, leave that. Alright, so this is the postcode address file, which is an extension of .dtd. You can see the DTD extension here. The file is .dtd, and if you select XML, you have different XML files, and all files, you have multiple files in this one. But let me go for DTD, data type definition. Click on open, and this is a DTD file, and next one is the root element. So whenever I just told you about the structure, so there will always be a root element. Under that you will have the leaves, like a hierarchical structure. So you need to go and select the root element, which is postcode address. And if you don't know this, the data owner, whoever gave you the XML structure, will tell you what is the root element and what is the leaf element and what is the depth between these three and all these things. Click on OK, and now you will see this one. If you select this file, right click and open this, once again. Okay, so I'll show it a little later, but now you select this file, drag and drop it into your data flow. It will give you 5 different options. One is make it as a file source, file target, and then message source and message target. So if you are working in a bad job, like just some blind rules, if you are working in a bad job and you are trying to deal with an XML structure, either you make it as a file source or as a file target. So if your XML is a target file, you make it as a file target. If your XML is a source file, you make it as a file source. And if you are working with a real-time job, which I haven't spoke about, but we'll be talking about it a little later, so you make it as a message source or as a message target. Remember this thing. So you tag this as a nested structure, and once you use that in the data flow, this is the second rule, make it as a file source. And this is only a structure. Remember, this is a data type definition. It is not an XML file. So this should be pointed to the XML file. So these are the 3 rules of XML. When you try to add XML structure to the data services, first thing, you add it as a nested structure, as a flat file. The second rule is, if you are using this in a bad job, you want to make it as a file source or file target. If you are using it in a real-time job, you want to use it as a message source and message target. And third rule is, you have to link this file with the data file. So this is where we link that with the data file. So click on the drop down, select files, go to your desktop, go to the folder where it is present, and postcode address is the XML file. Right, so this is the data file. Open this, and now if you look at the structure, it is not your plain structure. It has postcode group, under that it has the postal codes, and it has the address group, nt_1 group, and under that it has the addresses. So it is a nested structure. Now once you point this file to the data file, it will show you the magnifying glass. Click on that, you'll see the postal code. Double click on that, it will give you the 2 postal codes. Now double click on the first postal code, it will give you the addresses related to the first postal code, and double click on the second postal code, it will give you the addresses related to the second postal code. So this is in a hierarchical structure. Now how do I break it into a flat structure? Now let us start with a query transformation. I told you query, I praised a lot about it. Now connect with this and open the query transformation, and you will end up seeing the same nested structure, right? So pull this structure to the schema out as it is. Now see, this is grayed out and this is grayed out because this one is in current state, right? Now you select the second segment, right click, and it is not current, so you have to make it current so that the postal code gets activated, and then you have to unnest this one, which means it is in a nested structure. You have to unnest this one. There you will see an enter symbol here which says that it is unnested. Do the same process for the subsequent nodes. You can make it as current and unnest the structure. Right. So just go back and connect it to a flat structure, call it as XML_data, put it in your target data store, connect with your query transformation, validate it, select your job and run it. So once your job is done, the expectation is like this nested structure will be converted to a flat structure. Now go and open the table, and here you see this data converted into a flat structure. Initially it was nested, like it has a postcode group, under that it has 2 postal codes, SS019TB and DE150LQ, and SS019TB has 3 addresses and DE150LQ has 2 addresses. Okay, now this is how we read the nested structure data into a flat structure with the help of a query transformation, and all you need to do is go to each and every segment, make it current, and then unnest it. right? If you don't make it current, the unless will not apply on that segment, right? So these are few options that we missed in the query, which we'll be looking more in details when we are dealing with the XML structure. We covered two options. Now the next transformation is XML map. So this is something that is, which is not present in data services 3x. It is from the 4x version. Right? It is nothing but a query transformation for XML data. You see the same structure like query. You have mapping, iteration, role, where, distinct, group by, order by, advanced, and find. So this is nothing but a query transformation for XML data where you have a provision to directly drag the columns to the output structure. Right? Whereas in in a query transformation, you cannot drag this column directly to the output structure. It will not allow you. So that is the reason we copied the structure and unlisted that to be a flat structure. But now in XML map, it allows you to question from Adil, why are we starting at the postal code group level and not the below level? So the reason why I'm starting at the postal code level is, right, so this is a nested structure and I can just move it from here to here, and I cannot go and copy, or yeah, I think I can. And if I do it here, right, I'll be in a position to capture only the address but not the postal code. So that is the reason why I did it from the first node. Yeah, I got your question, Adil. So if I just do it from the postcode address, right, I will get only the address. I'll not get the postal code, but my intention is to convert that into a flat structure. Oh, from here, so you are actually taking the structure from here. This is just the name of the schema that you are sending it in. So you are not taking it. So we have another scenario going forward. If you want to add one more level to the data, we will add a query transformation and add one more level. We'll look at that a little later. But now we just need to take it from the structure that is defined by the data owners. So they will tell you from which level you have to read it. Okay, so this is pretty similar to a query transformation where you can do a mapping on this one. You can apply the business rules and you can just directly pull the columns to the schema out. Yes, Chandra?
And generally, table in database we have table structures, right? Data storing in tables.
Mm-hmm.
These XML structures, how it will save in databases within the like tables and tables or some other
No,
structures.
XML is a flat file. It will not be in any table. XML itself is a flat file structures.
So here,
Hierarchical is repeated data that is present in your table, right? So if you want to talk about an organization level data, you can have just employee number, department and all these things. But if you want to talk about the verticals, like again in that vertical you'll have software, in software you'll have SAP, in SAP you'll have BI, BW, BO, BODS team, and in SAP you'll have all the IDs, then in BI you'll have BI specific IDs. So it is a repeated data which you maintain in a hierarchical manner, right? So
so
this
here
is
target
not
also,
your hierarchical data.
so here
Sorry?
target also is flat file.
Target is a database table, Chandra.
So we are
We are trying to read the data from a nested structure and write it into a flat structure. So remember, this is a nested structure, right?
okay.
And we converted that into a flat structure. So that is the exercise that we just did.
Okay. So it is
Okay?
storing like a table
Hmm.
now.
Yeah, it is stored in a flat structure like a table and column.
Okay. Thank you.
Okay? Alright, so back to XML map. So XML map is like pretty much like a query transformation. It has one additional tab called as an iteration rule where you can go and ask the system to do a propose rule. So this rule tells like how many are, what is the relationship between this node and this node, uh, based on the data that is present in that. And rest everything is same. You can use a where clause, distinct records, group by, order by, advanced, and fine. Now if I connect this to the same table using XML map, right? Done. Again, you have a flat structure, but this is pretty much simple because in the earlier versions, whenever you have a large nested files, because right now we just did it for only 2 columns, right? You just had to drag two schemas to the right hand side and select them, and we used to go to each and every segment and do an unnest and start working on that, right? But now this transformation, which is an add-on, or which I can say is a combination of query transformation and XML pipeline, which we'll be looking at in a bit. So this makes our life a lot easy, especially when you are dealing with multiple nested structures. And the third transformation, which deals with the XML structure, is XML pipeline, which is the last transformation of your integrator set. Drag and drop it into your data flow. Sorry. Connect it with your source and with your target. And this also allows you to directly drag your columns from schema into schema out, but this will get only one header per line item. I'll show you the difference. So there is no iteration rule supported here, so that is an add-on you got in the 4.x version. So if you have a flat structure and only one header and line item, this transformation you can go ahead and use it. So it picks only first address for both the postal codes. So it reads only one line item per header. So that is what I mean to say, like one line item per header. This will not, this will not actually get the iterated data, or there is no iteration rule here. So it gets only first record out of it. So these are the three transformations which you can use when you have an XML source. So a question in an interview, what are the three transformations that supports your XML data? One is your query, the second one is your XML map, and the third one is your XML pipeline. And if they are asking you for a version specific question, like which are the what are the transformations that support XML data, then you can, in data services 3.2, you can say query and XML map. There is no query and XML pipeline. There is no XML map in 3.2 version of data services, right? So this is how we read XML data. We'll see how to manipulate XML data and how to create a real-time job out of it a little later. But this is how we read the XML data using query, XML map, and XML pipeline transformations. So with this, we completed platform transformations, and I guess like we covered in and out options of each and every transformation that we spoke about. So guys, practice this platform transformation with a lot of dedication, because these transformations are used 90% across your projects. Like use a combination of these transformations, or mostly you'll use a query transformation. So concentrate more on that and practice all the scenarios, different scenarios. Think about different scenarios, correlate them with your previous project experiences. If you are working on some other ETL tool, try to build the same cases, business cases using these transformations, right? So these are your platform transformations, and going forward, we will proceed with the integrated transformations in our tomorrow session. Guys, let me know if we can have a session on okay, I will talk about that a little later, but yeah. So in tomorrow's session, we'll continue with integrated transformations. We completed the platform, and once the integrator is done, then we will look at one quality transformation called as base match, which is free of cost transformation. The other ones, to work, you need to procure the licenses, and base match and best record strategy. And after that, we'll go and look at the admin tools, data services management console and central management console. How does administrator work? And after that, we'll go and look at the real-time jobs, manipulating the XML data in real-time jobs. And after that, we will see a quick introduction to SAP HANA and how do we load the data into SAP HANA using data services, what are the different provisioning mechanisms, and how data services have an extra edge over the rest. And after that, we will talk about a quick project orientation, like how do we, you know, how do we start with the project, right from the sales call till the hypercare, right? We'll see different phases of the project, and we will also try to understand where exactly each and every person gets involved. All right, so this is our training plan, and I think like right now what we are seeing are a bit more complex than what we started with. We just started with the flat file to flat file extractions, but now we are complicating it more. Now going forward, we will try to do more complex scenarios and try to learn the tools step by step in a more complex way. All right, so any questions in today's topic, guys? You can go ahead and ask your questions. Can you show the platform transformations using SAP tables? We already did that, Satyaraj. I don't know what you are asking. Let it be an SAP or a non-SAP table. It is just a table. So we already covered all the platform transformations. You want me to redo all the transformations one more time? Okay, guys. So it can see table for us, like it only differs when we create a data store. Like if for SAP you create a different data store, for database you create a different data store, for web services you create a separate data store. But ultimately, once the data store is created and once you import the metadata into your data services, everything is a table, right? So it is your source table and it is your target table. So there won't be any difference between your source SAP table or database table. It is just a table, right, which has a column and row structure in which the data is present. So some ups and downs will be there, but probably when you are stuck somewhere, leave the topic and go to the next topic. That is one good suggestion I can give you. Don't waste your time on that topic, because we are talking about each and everything as a different scenarios. Like leave that scenario, try to figure it out and try to fix it yourself. But if it is taking a lot of time, leave it. I'm there to answer that question in the next session. So go and proceed with the remaining topics, and try to gear up and be on speed. By the time we complete the training, I guess like you will be in a position to practice each and everything, and we have a last additional sessions where we talk about the project orientation. So that will be only the theory. So by the time you complete all your transformations, everything, at least do it like each and every scenario 4 to 5 times, so that you just by heart that. And once it is done, by when we talk about the project, if you have any questions on the transformations, you can go ahead and ask that. I'll be able to answer those questions, but definitely I'll tell you I'll not have that enough time to repeat the same answer again and again. So just utilize this time, practice more, and get back to me with more questions, because every day I'm asking for questions. I hardly see one or two. So I recommend you guys to practice a lot. Alright guys, thanks for joining today's session. Have a good day and a good evening, and good night. We'll catch up again in tomorrow's class. Till then, take care and bye.